Oh, here we go. Back on live. Oh my God. We had some hiccups. I think it started from my Wi-Fi went out, and then it cuts off the live stream, and then I tried to get back onto it, and then might have pressed the wrong button or something. Anyway, so the original solution worked. All right, it worked. I mean, the Wi-Fi cut out, so wasn't able to show how we arrived at the end. But basically, what we're doing is like we planned, right? So it's a recursion, and this is the edge case, right? The terminating case. So low larger than high, so the low and high are 2 pointers. If the low point and larger than high pointer will return 0, that's fine. And if the low point is a 0, which means the current low high, so think about low high as a substring of the original string. If the substring starts with a 0, then there's no way to decode it. So immediately return 0. So we get these situation now. And then we're going to do take one or take two. So take one means we take one digit at the front, right? And then we use DFS to check the remaining. And then the total number of decoding ways when the one is taken out will be the total number of ways that the remaining can be decoded. So this is take one. Now take one, we have an edge case, which is this is the edge case. If we're looking at a single, right? The low and the high is the same, so we're looking at just a single digit. And because we take away 0 already, so this one will return 1 immediately. If not, then we can always take the single digit, and then we use DFS to get the remaining, right? So that one is out of the system. Next one is take 2, so we take 2 digits at the front, right? And then we compute the remaining, DFS on the remaining. So the requirement is the 2 digits at the front, low and the low plus 2. So this is the substring. It has to be smaller than 26, right? Because that's the that's how big the English letter can go to. So if it is smaller than 26, then we can decode it. So we take the first 2, and then we get the remaining. But we have another edge case is if we only have 2 digits left in the substring. If that's the case, we're just going to return, so rest is going to plus 1, right? Otherwise, we're going to plus whatever the remaining give us, right? And if it's larger than 26, then we don't do this part. Then we return rest. And we remember to memorize it so everything will be faster. So to call the total is just call 0 and the end, and boom, we're done. So it's pretty fast, right? It's pretty fast. However, if we can do it this way, we can definitely do it bottom up. That's the challenge I want to try right now. So to do bottom up, let's go back to the problem. Let's go back to the problem. Yeah, and it's a simple DFS. So that's what it is. So I shouldn't check it, right? I should not check it. Anyway, so bottom up will be, how do we do bottom up? I mean, for the bottom up, we can say it's going to be low and a high, right? So the DP table is going to be the 2D array, right? And 2D array, this is too complicated. Let's use 226. I like 226, right? 226, and we have 3 rows and 3 columns, right? 0, 1, 2, 0, 1, 2. So we can handle the diagonals. Diagonals are each individual, so each individual will be 1. And then we can consider 0, 1, right? To do 0, 1, which is 2, 2. So to examine 2, 2, we say we need to know 0, 0, right? We know 0, 0. If 0, 0 is a 1, then we can check 1, 1. Now 1, 1 is a 1, so 0, 1 we have a 1. Or we can take 0, 1 together. Oh, we have to do that one as well. So every 0, 1, 1, 2, every sliding window of size 2, we have to handle it as well. Yeah, so 0, 1 is going to be 1, and then 1, 2 is going to be a 1 as well. Now we go back, so that's the baseline. So 0, 0, 1, 1, 2, 2, and a 0, 1, 1, 2. These are the baseline. Once the baseline is done, we go back to 0, 1. We go back to 2, right? Or 0, 1. So 0, 1, will be, no, that's actually more complicated than it is. I don't like it. We should do 0, 1. Yeah, we'll do 0, 1. So 0, 1, we're going to take 1 and take 2. So take 1, we take 0, 0, and then 0, 0 is a 1. So we're going to check 1, 1, so that's a 1. And take 2. So 2, 2, take 2, that's a 1. So 1 plus 1 is 2. So 0, 1 has 2 ways, right? And then we have to do 1, 2, right? We have to do 1, 2. So when we do 1, 2, we take 1, do 1, 1. Now 1, 1 is a 1, so we look at 2, 2, that's a 1. And 1, 2 is a 26, so that's a 2 as well. All right. Now we take a look. So this is the size of 2, now size of 3. The size of 3, we're going to take size of 3. So we take 0, 0, right? And 0, 0 is good. So we need to take 1, 2. So 1, 2 is a 2. So we get a 2. And then we take size of 2, which is 1, 2. 1, 2. 1, 2 size, it's a 22, so that's a 1, right? And then we check 2, 2. So plus 1, that's going to be a 3. I think it will work. It will work, right? So basically we do diagonal first, and then we're sliding with to, I think it shall work. Let's try it. So solution 1 and a solution 2 will be bottom up. So dp equals to 0 times line s, and this for underscoring range line s. I'm pretty sure we have to use line s again, so n equals line s, and all the line s will be n. All right, and then what we're going through is the length. All right, so we say for size in range 1 to line s, that's the size. Then for I in range 0 to len s minus the size. So size is 1, minus 1. Should we plus 1? Minus size. Alright, minus size is this. And I can only do this. So I think that should be plus 1 as well. So for I in this, right? And we say if j, right? We have a j. J equals I plus size minus 1. I plus size minus 1. So plus 1. Yep, I plus size minus 1. And we say if I equals j, right? Then dp ij plus equal to 1 if si is not equal to 0. Else, if this and si is not equal to 0, then we plus equal to 1. All right. Else, yep, else. Now I is not equal to j, right? Now we can say we take 1, all right? So let's say take 1. How do we take 1? If dpi not dp. Yeah, if dpi take one ii, right? If dpii is not 0, yep, if it's 0, then that's the moot point. If dpii, then dpij plus equal to dpi plus 1j, right? So that's take 1. Now take 2. If how do I take 2? Take 2 is if int si to I plus 2 is smaller or equal to 26, right? Take 2. We run out. Nah, let's see. Take 2. Yeah, we'll be able to take 2. So it's this. Then what? Then we say dpij, right? So take 2 plus equal 1 if j is equal to n minus 1. So we're already at the end, right? Else, we can do dp I plus, so it has nothing to do with j, it's I. If I plus 1 equals j, else I plus 2 and j. And that's same as this one, right? I plus 2 or j. Let's take 1, take 2, else take 1, else this is 2, and that should be it. Then I'm going to return dp 0 and n minus 1. Let's try. I index out of range. I suppose it might happen. Why is that? All right, we have a lot of issues. So we start from here. Let's just check. That's wrong, right? So size 1 to linus. Okay. So size is 1. Line is 2. 2, so I to 2, so 0 and 1. That is correct. And j equals I plus 1 minus 1. J equals I. So it's all the same. Plus equal to 1, which is perfect, right? We're good. And then come back up. Size will equal to, oh, we didn't do the size. Plus 1. Okay. Let's try these. Okay, so we pass the 2, but we don't pass this. Okay, so we have a single one. That's times 1. So it's just, okay. So for size, it's going to be 1. So I in len s is 1. Len s is 1. Minus 1 plus 1. So I is 0. 0. J is 0. So 0, 0. And it's not equal to 0 to this. Now SI is 0. Then we'll go in here. No, it should be if this equals this, while if si is not equal. Alright, so we can just do this. If si is not equal to 0. If it's equal to 0, then we don't do anything. And then we can handle everything else. So we can do this, and this, and this is going to be else. Right? This one will pass. Yep, and that's a bottom up. Right? And not necessarily faster, I think, especially because this will be the second time we run it. So it's not necessarily faster, but it's good practice. Yep. Oh, it's not ready yet. I have to refresh. Yeah, it's not necessarily faster. It's to 112. I mean, the reason is we're doing looping, right? We're looping ourselves. And usually when you loop yourself, it's slower than the you push on the stack, which is optimized. But we do have this bottom-up solution, which is the same. It's the same, I think. It's the same as the other one. Well, actually, it's not. You know, we might be computing things we don't need to compute. Say if it's 0, then we don't keep going, right? Yeah, I think if it's 0, shouldn't we just escape? If I have a 0, right, and then I is 0, and we have a j, and anything moving on is a moot point. Hold on, are we saying, yeah, if I is 0, if I have a 0 something something, right? So we know from this going on, anything is not gonna work. Like even if you compute, these will not affect. Huh, hold on. Yeah, I think, what if I just say, if this equals to 0, then we simply break. It will pass here. Let's try. Yeah, we simply just break it. We simply just break it. Because we don't need, right? This means if the current start is a 0, then for the current length, for the current size, it's going to be nothing. And for anything following on, it's going to be something, but because we have 0 here, so they're not going to count. I'm not 100% sure, but yeah. And then let's just throw in some 0 inside and see how this one goes. I think it should be right. No. I cannot do that. I cannot do that. Why? If si is 0, then we don't do it anymore. Oh, we do need, because if I take this, I do need to do the remaining. Ah, okay. So no. We do have to. So it's not going to be break. It's going to be continue, right? It's going to be continue. Yeah, it has to be continue. All right. Anyway, all right. Let's go take a look. Yeah, we've done this before. 91. Yeah, definitely. When's the last time? Look, we did it 2019, July 17th, 2019. I actually solved it back then too. I start from 245, the first solution, and then I got it somewhere. Let's see, what type of method I used back then. I use memo. Yeah, I think it's the same idea. Same idea. And did it again, December 26, 2020. All right, that's just end of last year. We did it. And what type of method did I use? There's oh, that looks better than this DP method. If Si is not equal to 0, then dSi plus 1 equals dSi. If I is not equal to 0, else 1. If I less than 0, and then this is in this, then I plus 1 plus equal to ds. Oh, yeah, this seems to be easier than this. Ah, okay. So we're saying iterate I through this, right? And then we say if the current one is 0, then I have to look. If the current one is not 0, then whatever the previous one has, I'm having it. Yes. If larger than 0, and we have the previous one, so this is I, right? So it's I minus 1 to me. If this is then it's I minus 1. It's I minus 1. So I plus 1 will equal to is I minus 1, everything. This one. Oh, this is good. This is better. Better than this bottom up. This is better than this bottom up. Did I write? Alright, so how about the last solution I get? Oh my god. Previous letter. ON. So that's probably ON is not ON squared. It's ON. It's hard to detect in here. It's the same idea. It's the same idea, but with this. Nah, it's not gonna do this way. Let's try this one. I don't like it. I like my other one. Yeah, I like the other one. I'm gonna try one more. Yeah, I like one of the earlier ones I had. Done this already. 91. LeetCode 91. Alright, so this bottom up is stupid. Basically, it's trying to translate from this, right? But it's just stupid. And it's ON squared. This one is literally ON squared. This one is ON. This one's ON. How is this one ON? We have low and high. Oh, your high never moves. Ah, that's why this is on. I mean, I can do this. I can just say I, right? And then I can just say if I is smaller than, just do len s, right? I smaller than, no, if I equal to len s, or si equals this, right? And then this is going to be I equals to, let's do n equals len s, right? So if I equal to n, that's a no-go. If I equals to n minus 1, that's going to be this. Otherwise, we're going to do I plus 1. And this is going to be I and I plus 2. Rest us if I plus, if I equals n minus 1, no, I equals n minus 2, else I plus 2, right? And then we just need to return the 0. And this makes more sense. Ah, I see. Solution 1, yeah, that's on. Update. Just realize that we don't need to do low and high because we never change. We never change high. In other words, this is a 1 D array DP. Bottom up. This is on squared. This one is slow because it is on squared. This one is going to be a better DP. Better DP. The same method that we used back in December, right? December 2020. So what we have so any one, if it's one value, yeah. So we start from the front, right? If it's one value, then we're gonna use something. We take it by itself. We take I by itself, right? And then we do I minus 1. Wherever from start to I minus 1. So we just say we go all the way to the end. That's the 1, right? So at any I, dpi will equal to the total number of way we can decode in this. So we have dpi, dpi minus 1, right? So we just need a pre and pre. P and pp, right? P and pp both are 0, starting with 0. And we have also the current, all right? And we say for I, right, for anyone, current one, I'll check if it's 0, then it will equal to, if it's a 0, we cannot decode 0 by itself, right? So it has to be decoding 2, right? 2 together, and then we get this. That will be the current. And then we move on to the next one. So what we're gonna say is for I in range, actually, do we need I? Yeah, I in range len s, right? We say if I is a 0, then So I can be a 0, I can be not a 0. So we say if Si is equal to a 0, right, then current, right, will equal to, if I is a 0, so the current one is a 0, then that should equal to PP, right, PP if actually we can say times this if S I minus 1 to I plus 1, right, this, and we can do int. If int this is smaller or equal to 26, right, else it's going to be 0, which I think we can just do times because we'll evaluate to 1. So current will be just taken 2. So we take 2. Else, if Si is not a 0, then current will equal to this, right, plus P, the previous one, right, the previous one. So we take the current one and the previous one. And then once we're done, we're going to say PP equals P. So we're going to say PP equals current and P. P equals current and PP equals P. Right, then I'm going to turn all the way to the end. At the end, current, so we'll return P. Let's see, not sure. Invalid. Okay, yeah, this is base 10. Which one? First one. It's not equal to 0. Then, is that why we have to do the other way? I minus 1. Ah, I see. Yeah, so, oof. What if I use this? Not sure if it's going to be working better than the others. Only concatenate str, not int to str. Probably have to do a parentheses. This I want to evaluate to an integer. Okay, so they all return 0, which is not what we want. Let's see. Plus P. We didn't take care of. All right. So maybe what we should do is at least get a P, right? So we can say P is equal 1 if S0 is not equal to 0, else 0. And then this will be from 1 to the end. And still not correct. The initial, we have the, oh, shouldn't that be PP? P is previous, PP is previous. So if previous is 0, and P is 1, yeah, that's true. Previous is 0, right? So say the first one is a 1, right? So we come in, this is false, so current is 1, which is pointed here is 1, right? And then let's just print P and PP after each one, P and PP. So 1 and 1 after the first. Hold on, we start from here. And then it's a 0. No, it's not 0. So equal to PP. Oh, PP shall be 1. Let's see. How do I handle that? Because my initial PP is 1, is 0. Are you saying that we should be doing 1 initially? Both are 1. If we do both as 1, I mean, this is already handled. And if it's true, then I'm going to return 1. Right? Which is, actually it's not plus P. Hold on. PP is the total number of ways, right, ahead of us. And P is the total number of ways, 1 ahead of us. PP is 2 ahead of us. And what we're going to do is we check the current one. If the current one is 0, right? Then we have to do 2. All right? And then this one is correct. I think this one is correct. If the current 2 is within the range, then this one evaluate to 1, and then current will just equal to that. If it's not equal to 0, right? So we can take the current one. We take the current one, then we plus P. That is correct. Or we have 2 and we times PP, which is correct. Then what is the problem? Well, the problem is the PP. So where are we looking at? That's the problem. I should, wait. It's the current, right? So current, we're pointing to the 2, right? And then P, this one we already do is 1, plus PP times, and this is true. Ugh. If it's true, I shouldn't say times, right? But what if the previous one is? But you're saying we should get both to 1. What is the logic here? This previous number of ways, right? The previous number of ways is 0, is no way. So But that's the first way. Then we have to write extra logic here. Which means I don't like how this one is going. I don't want to write extra logic. That's why I'm stuck. So we start with 0, right? And then we have to do extra check. Let's see if we do extra check here. Yeah, so these two, yeah, what if it's like 1, 0, right? If it's 1, 0, then we're gonna fail as well. Maybe we should start with all 1. Let's see if we start with all 1. Maybe we should start with 1, right? And then these pass, but these fail. Yeah. I think we should start with 0. And of course, this we should start from here as well. What we're going to do is current equals this, right? I just have to do it. If I is I God. I don't like it. What's the best logic for this? If SI is 0, right? So the current one is 0. So I look for 1 before me. So I plus 1. So this is the current of 2, right? And then PP is the one ahead of me. But we start with 0, right? We start with 0. Therefore, we should say equals this. If we do have I minus 1, right? So it has to be I is larger than so times 1. If if it is 0, right, then we shall times 1. So I think it should be this times 1 if I is equal to 1, right? Else PP. And here, if it's not, then current equal to same thing. So whether it's 0 or not, this will do no matter what, right? And after this is done, then we say if it's not equal to 0, right? If I is not equal to 0, then what we're going to do is plus equal to p plus equal to actually 1 if I is 0, else p. So we can just do that. Now we all pass. Yep. However, I still feel, but that is the logic, right? That is the logic. Yeah, this one is struggling on this. Yeah, so this is O(n) time and O1 space. I mean, it's not as elegant as Pachmann's solution, but this is something I can understand. P and PP, all right? I should actually let me keep writing this. P is the number of decoding from decoding in S0 to I to I. PP is the number of decoding in S0 to, actually we should just do this, I minus 1, right? Thus, to find the number of decoding in Si plus 1, we first take 2 situation, which is to take Si minus 1 to I plus 1. All right, we check this situation first. Then we take 1 situation, which is take Si by itself. Yeah, that should be good enough. Submit. Yeah, that's O(n). That's O(n). Yeah, that's O(n). All right, that's it. I spent a long time on this today, even though I think we finished it in like 7 minutes, but it's good. Revisiting old questions and then got bogged down into, oh my god, how is this working? I kind of don't know. Yeah, I mean, this is my way of solving it. It's easier for me to understand. Anyway, that's it. I'll see you guys tomorrow. Adios.